So hello and welcome back to another exciting lesson. This is Math 140, lecture number 7, I believe. You are?
I'm Jack.
You're Jack. Okay. Hello, Ariana. Yes. Awesome. I got in real trouble once. Well, I actually didn't get in real trouble, but I was subbing for a class once, and it was during a test. So I had a roster of everyone in the class. I'm supposed to mark them off as they walk in. So, you know, I got there like 10 minutes early. I mark everyone who was there. And then as people walk in, played a little game with myself. I kind of looked down at the roster and kind of look at them and try to guess their name, right? It's a little fun, right? So this guy walks in and he happened to be Asian. And I look down at my list and I'm like, Xingwei? He's like, what? I'm like, what's your name? He goes, Jimmy. I'm like, okay, shit. All right. Well, anyways, so I don't try to be better at that now. So Math 140, lecture number 7. And we are starting chapter number 5. Which is on, I think it's on regression. I think chapter 5 is on regression. Now, this is the last chapter that will be covered on test number 1. If you recall, we decided that test number 1 is going to be what, 2 weeks from today? So chapter 5 is on regression. So let's recap what's going to be covered in the first test, chapters 1 through 5, obviously. 1, visual displays, pie charts, bar graph, that kind of thing. 2 was what, measures of center and spread. 3 was the normal distribution and all its applications. 4 was on correlation, and 5 is on regression. So after today, we will have at least 1 day of just nothing but review, answering questions, doing problems from the workbook, possibly even 2. I looked at the calendar for this class, and it looks like I might even be 2 days ahead of schedule. So if I am, and we might have 2 full days to review rather than just 1. So chapter 5, regression. So what exactly is regression? Well, so you have a scatter plot. Whose way? I meant obviously Johann. Yes. Okay. So you have a scatter plot. You got a point, 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 you got a point. Right here's your scatter plot. Last time when we did scatter plots, we talked about a few things. One of them was form, linear versus nonlinear. Would you say that this is linear, or would you say this is nonlinear?
Linear.
I think it's kind of linear. Seems like it's fitting close to a straight line. Remember, in statistics, linear does not mean it falls exactly on a line. It just means that the overall shape is like a line. Positive or negative? Positive seems to be going up. Are there any outliers? Doesn't look like there's any outliers. If I added a dot here, it would be an outlier, but it doesn't look like there's any outliers. And strong, moderate, or weak. Hard to tell without a scale. As I mentioned, we always want to have a scale whenever we look at it. If we zoom in on anything, it can always, from the eye, change from strong to moderate to weak. But I would say if this is a, not deliberately trying to trick you, moderate to strong, somewhere in that vicinity. So once we've established, when we look at the scatter plot, that we believe that there is a linear relationship, the next question we want to ask is, what is the linear relationship that we believe models this scenario? In other words, would you say that this is a likely candidate for the actual line that all of my points scatter around? No, that's obviously not correct based upon my sample. Would you say that this is a possible candidate? Seems much more likely. Of course, if someone else said, no, I believe it's that. Hey, Alan, how you doing? I meant Steve, what's up? How are you? Josue.
Yes.
No, third time's a charm. So I have two lines of error. From the eye, does one of them seem like it's better than the other? No, I can't really distinguish, but I mean, certainly these are better than that. I can do that, but know which one of these is better? Hard to do, if not impossible. So if you go to your calculator and you put in all your data and you ask your calculator to give you a best fit line, it will give you a very specific line. And you don't get a different answer using a different calculator. All calculators will agree on what the best fit line is, which means that there is a very specific line that is the best fit line possible. So the mathematics of regression or regression analysis is determining which line is the appropriate line for the data. And if it was nonlinear, and I believe it was exponential, I want to fit an exponential curve, or a quadratic curve, or a cubic curve, or a logarithmic curve. Whatever the case may be, regression is the branch of mathematics, the branch of statistics that tries to find the best fit line. The question is, what is the criteria for the best fit line? Would you say that a valid approach to finding the best fit line is the line that goes through the most data points? Do you think that might be the only determining factor, or even a determining factor for the best line? It could be a determining factor, but if I gave you the following scatter plot, if I gave you those four dots, and I said, what's the best fit line? I'm thinking, well, a little off, but I'm thinking something like that might be the best one. Kind of splits the gap, you know, like touchdown, you know. So by the way, go Rams, right? But anyways, so this one doesn't go through any of them. Yes?
I might be jumping ahead, but would we use standard deviation to find a line?
No, but thanks for playing. So it's a good guess. Again, I don't care right answers, wrong answers. I just love people participating and trying. I do remember that at the end of the semester. Those faces to names to voices. I'm like, oh, that person really participates a lot in class. That person really tries. Oh, they almost got an A- or an A. Okay, I'll bump them up. Okay, they had a C. I like them. I'll give them an A. Okay. So, you know, go for it. Just try. So no. So the question is, what makes this line here better than, say, that line there? Which line of those is better? Well, maybe, here, let's do this. This line, or maybe that line. Which one of those lines is better? Each one splits the data pretty well, yes? So why? What are you using to determine that? I'm sorry? Correlation plays a role, but it's not enough by itself. Yes. I don't know. I mean, yes. From a quick eyeball perspective, you're right. You're right. But I want to have a mathematical way of determining the best fit line, because I don't want to do it by eye, because then someone else's eye might be different than mine. I'm not a very good artist. My pictures are not great. So mathematics is much better. Yes.
Each dot is closer to the line.
Well, yes, each dot would be closer to the line, but in a way that's very specific, which is what I want to get into now. So I have limited space here. I have to erase and reuse, but so here's the idea. If you have a bunch of dots. I'm only going to put 4 dots in just for clarity of visualization. But remember that in an actual scenario, you probably have dozens, if not hundreds of points that you're analyzing. If I come in with a line and I say, this is my best fit line right here. So here's how we do it. What we do is we measure the vertical distance between each point. I'm going to move this up a little. We measure the vertical distance between each point and the line itself. Now remember, we don't know the line yet. So we're doing this for a hypothetical line. We're just hypothetically putting in a line and measuring these vertical distances. These guys are our observations. And the points on the line that corresponds are our predictions. In other words, why are we even getting a line in the first place? Because the line is going to help predict. If I had this X value and I wanted a data point for this X value, what would be its Y value? Well, best guess, go to the line. If the points scatter around the line and you have no information, take the point on the line. It's the best possible prediction that you can make. So the lines, the points on the line are your predicted values. The difference between them, those are called our deviations. The deviations or the residuals. The book uses both of those terms interchangeably, deviations or residuals. And the formula for the ith deviation, every data point has its own deviation. So the ith deviation for the ith point, this is x sub I, comma y sub I. It is the ith data point, is going to be the actual observation minus the predicted observation. So we use a little hat symbol to denote the predicted value for that ith point. So again, we have the first point, second point, third point. This is the ith point. And the ith deviation is the ith value. Sorry, these should be y's, not x's. My apologies. We're looking for vertical distances. So the y value minus the y value, not x value. The deviation is the actual yi, the ith y value, minus the predicted one that's either directly above it or directly beneath it, or magically the same if it happens to fall on the line. Are all deviations positive? Are all deviations negative? Are some positive, some negative? Sorry? Based upon what consideration? How do you know by looking if the deviation is positive or negative?
Based off the strength of it? Or?
Not the strength, that's the size of it. Yeah, if it's above or below. If it's below the line, then this value is smaller than that value. The actual y value is smaller than the predicted y value. You have a negative deviation. If it's above the line, then the actual value is greater than the predicted value, and you have a positive deviation. If you add up all the deviations, then what happens is you have a cancellation effect, because some are positive, some are negative. So what we're going to do, and again, we're going to let our calculator do this, is we are going to take all the deviations, we're going to square each one of them. Now we don't have any negatives anymore, right? Now all the deviations are positive, and then we're going to add all of them together. We're going to sum from I equal 1 to n. This is the first deviation squared plus the second deviation squared, all the way up to the nth deviation squared. Hey, Alexis. Hey, Sarah. How you doing? Great. So nice to see you. Sit anywhere other than a seat that's already taken. So that seat's fine, I think. That should be fine. So this number that we get, is for this line that we imagined. Now we do it for another line, and we calculate its value, and then we do it for a third line and calculate its value. In fact, we do it for all possible lines. Now, how many possible lines are there? Hey, Emma, what's up?
Sorry.
Was that right?
Yeah, you're
Oh,
right.
okay.
Yeah, 100%.
Phew.
I was drinking.
Okay, I can't be wrong every time. All right, so how many lines are there in theory? Is it possible to make through our data?
Infinite.
Infinitely many.
What is the Y with the carrot on top?
Y hats, this is the, this is
What's it called? Y hat?
Y hats, yeah. That is,
I know what it is. I just don't know what it's called.
yeah. Where's it? Shit, that's on camera now. Oh, I was off camera, that's okay. Steve, what's up? Ah. Okay. All right, so we do this for every single one of those infinitely many lines. And then pick the line that makes this as small as possible.
So the sum is supposed to equal close to or 0?
The closer to 0 it is, think about it. If all the points fell on the line, all my deviations would be 0, correct? Then the sum would be 0, and I have the correct line.
Does it ever equal 0?
Only if all the points fall on the line, which is very rare for it to happen. Very. Very rare for that to happen. The harder question, or the better question, how do we do this for infinitely many lines to determine which one has the smallest value? That's the question that we should be asking. And the answer is you don't. Because a guy about 300 years ago was a pretty smart guy. His name was Isaac Newton. Anyone hear of him? They went to the Fig Newton? Yeah. So Isaac Newton. And he came up with what? What did he invent or discover or help create? Calculus. Determining which line is best is about 4 or 5 lines of multivariable calculus. So calculus, one of the tools of calculus, one of the strengths of calculus is picking amongst all of the infinitely many possibilities, the one and only one that makes this as small as possible. And what we get is called the least squares best fit line. Seems very appropriate name, the least squares best fit line. Do we understand why it's called the least squares best fit line? Because how does it best fit the data? By making the sum of the squares as least small, as small as possible. Now, luckily, much later than Isaac Newton, there were some guys like Alan Turing and others who did what? What did Alan Turing help basically proliferate? Well, computers in general. So now we have calculators. And the calculator can do this in about 30 seconds. Most of that time being you inputting the data. So you input the data to the calculator and you say, calculator, can you please calculate the best squares, least squares best fit line for me? And it says, no problem. And it does it. So we don't have to do it by hand. We will never do it by hand. That being said, we should know the formula for it because you could have a question on the test that references the formula. But in terms of actual application, finding the best fit line, you'll always have your calculator do it for you. So are there any questions so far on what regression is and yeah, on this stuff? Yes.
Does that always stay the same, the formula at the top, DI?
Yeah.
I?
It's just depending
In that order.
depending on the line, you're going to have different deviations.
Right, but it's always YI.
Yeah, it's always the
Y
data
hat.
point minus the predicted value. So that if we are beneath the line, it is always negative, and if we are above the line, it is positive. Yes.
What's the textbook definition of regression?
The textbook definition of regression is fitting lines or curves to your data. In our case, we're only worrying about linear fit. We're not caring about fitting curves. If I had data that looked like this, I teach at a high school in Burbank, and anyone ever hear of the International Baccalaureate? It's like, it's basically, it's an international approach to learning and whatnot, and they do things very differently mathematically than we do here in America, but they do a lot of regression and nonlinear. So if I had data that looked kind of like this, and I said, I want to best fit this, I would not tell my calculator to find a line that best fits this, because the data does not look like it should be linear. What does this look like it should be? What?
Like a parabola.
Well, no, this is certainly not a parabola, because a parabola would be here, fine here, or here, but it wouldn't be this. So who, a sine curve, a sine or a cosine curve. So you can go to your TI-84 calculator and say, fit the data to a sine curve. And that's still regression, it's just not linear regression, so we're not going to do it. So the first task of a regression problem should always be make your scatter plot and then decide what is the appropriate model for the problem. Do you think it should be a linear model, in which case do linear regression? Should it be a sinusoidal model, like sine curve, quadratic, cubic, etc.? And then let your calculator follow the model.
But we're just gonna do linear.
We're only worrying in this course about linear. We're not worrying about anything else. So the least squares regression line. So what are the formulas for the least squares regression line? So we know it's a line. What is the formula for a line? Who remembers their algebra? What is the formula for a line? Y equals mx plus b. Of course, in our case, we're going to call it y hat equals mx plus b, because the hat is the predictions that we're going to make, and the predictions is basically the line. Yeah?
Just back on the sum of the DI squared, so that's the sum of all the deviations.
Yes. You add up all the deviations, and you get a number. You get a, I'm sorry?
And then find the smallest.
Well, every conceivable line that you might draw is going to have a value when you add its deviations.
Right.
Go through every single line in existence, all infinitely many of them. Whichever one gives you the smallest of those is our line
You're adding up the deviations for each line.
for each line.
Okay.
And again, as I said, we can't do this in practice. There's just too many lines. So we let calculus do it for us. Anyone here taken multivariable calculus by any chance? Regular calculus by any chance? 1, 2, 3, 4, 5, 5, 5. Well, calculus is a lot of fun. You should all take calculus. Emma, you gonna take calculus?
I dropped out.
Good talk. Okay. So calculus is a lot of fun. I haven't taught it here for a few years, but it's fun. It is. If any part of math could be considered fun, which is already very questionable. So the regression line y equals mx plus b, or y hat equals mx plus b. What does the m represent in regard to the line? It's the slope. And what does the b represent in regards to the line? The y. Technically, it's not the y-intercept, because technically the y-intercept is a point, not a number. And therefore, b is a number. So technically, it's the y value of the y-intercept. But very few people would really care about that distinction. And if you just call b the y-intercept, nobody's going to kill you. Well, most people. So the slope is represented by the letter n. The y value of the y-intercept, or just the y-intercept, is b. And then x and y hat don't get numbers. X and y hat stay in your answer. Your answer will have the letters x and y in there, because we want to come along later and say, well, what if x was this? What would y be? And you say, okay, no problem. Let me plug your x in and calculate, and I'll get y. So x and y stay there. They're variables. The only thing you put into your equation is the slope and b. And for those of you who need a crash course in this particular topic, if you have a line that is not vertical, then we know that the y-intercept is the point 0, b, and the slope. What's the formula for the slope?
Change of y over change of
change in y over change in x, delta y over delta x. Delta is the traditional symbol that we use for change. So delta y over delta x, a change in y over a change in x, also called a rise over the run. So we calculate these things and we have our line. And if the line is not vertical, then we have a unique line, and that's our line. So when we have our calculator pop out the answer for us, basically the calculator says, oh, here's the slope and here's the y-intercept. That's all it has to give you. Yes.
Why did you make the distinction of putting y hat?
Because y, our data points are y.
No, because like in like algebra class, they'll
Turn that off. I'm kidding. I don't care. You can answer. It's important.
no,
It could be an emergency, huh?
that's my timer for something. I don't know what, but
Okay. So I know what it is. When we were online, you'd leave class and you'd come back before class was over to make sure that you were there at the end, so you get credit for being there, right?
you said it.
Ah, okay, I get it. So y hat. So what's the distinction? In algebra, there's no context to a line. It's just algebra. There's no physical understanding of what x and y are. We just do mathematics. Y equals 2x plus 7. Let me graph that. Here, y has a very specific interpretation. It is the predictions that we would like to make from our data for any x value that you provide later. Right? When I have my scatter plot, these are the dots that I have. Those are my dots. Those are my points. I come up with a best fit line. Why? Because I say, well, what if x was this? What would my y be? And you say, well, I'm going to guess that. I'm going to use the line to give me the best guess for that x value.
So it's not an exact answer.
It's a prediction.
Estimation.
It's a prediction.
Oh,
You know, you can have a study that says, I want to open a restaurant. And I have this data that says that the further I am from campus here in Northridge, the less revenue I'm going to get. Because, what do kids do? They're students. What do you guys do? Oh, I have an hour break. Let's go to eat somewhere. Where are we going to go? Oh, we're not going to drive 2 hours away. We don't have the time. We're going to go somewhere close. So I have this data that says how much I'm going to make based upon my distance. And maybe I do my scatter plot and it's linear. And I say, well, I'm looking at a property that's 3 blocks away. How much am I going to make? Well, I can't tell you what you're going to make, but I can predict that you're going to make about that. I'm going to use the line to make a prediction in the future. Then you can say, that's not enough. Let's find me a better place that's closer. Or, hey, that's fine. I'm good. Let's go through with it. In a real business scenario, you probably do a little more due diligence, but it's a very basic situation. Does that make sense? So in our case, what is y hat? It is the predictive values. Now, the slope that we're going to have for our best fit line, to be honest, I don't even memorize these because I never use them. I just use the calculator. So the y-intercept, or b, is r times s sub y over s sub x. What do each of those symbols mean? What's r? R is not regression. We haven't defined a quantity for regression. We do have a quantity defined for R, though, from last chapter. What was the R that we defined last chapter? Correlation. Our two variables are correlated. That's the correlation coefficient. What is S sub y and what is S sub x?
Standard deviation value of x value and then y value.
I assume you meant in the opposite order.
Yeah.
Okay, good. Otherwise, it'd be very confusing if we did it that way. So yes, so the standard deviation of the y values, the standard deviation of the x values, and R is the correlation, all of which the calculator gives for us. We don't have to compute any of that. We plug it into the calculator, it gives us everything. Now, last time we saw, or at least mentioned, that if I switch my x and my y, my correlation coefficient stays the same. Okay, two variables are correlated or not correlated, or how strong they're correlated. I don't care the order that I look at them. I just get one single value. But if I do switch these, then I switch those, which means the y-intercept does depend on what my x is and what my y is. Okay, so it's important for correlation. It's not important for correlation. For correlation, I don't care what X and what Y is. But whatever you're trying to predict from the other, I'm trying to predict revenue based upon distance. The thing that you're trying to predict should be your Y value. The thing that you're using to predict it, those are your X values. Meanwhile, my slope is Y bar minus B X bar. Oh shit, blah. Again, I don't use these often. These should be switched. I'm very sorry. Sorry for following along at home. I apologize. The slope should be R S sub Y over S sub X. And the intercept is Y bar minus B X bar. Again, I'm sorry, I don't use these often because I just have my calculator, so I don't have it memorized. Yes.
So the slope is the one that says.
Yeah, so the slope depends on which one is Y and which one is X, but so does my Y-intercept, because my X bar, my Y bar are not going to be the same. And my B I see. Make this M here. Okay, again. Why would it do that? Oh, I see what, okay, I see what it did. The book uses this formula here. Y hat equals AX plus B. That's what the book uses. They don't say MX plus B like normal people. They do AX plus B. Or they don't even do that. They do A plus BX. This is what the book does, which is horrible. Because we're so used, and I'm so used to thinking of B as the Y-intercept. So that I made like 19 mistakes in the last 30 seconds. And again, my apologies for all those. But Y hat equals MX plus B. Even if you don't care about the letters, the slope is given by this formula here. R S sub Y over S sub X. And the Y-intercept, or the Y value of the Y-intercept, is given by that letter, that value there. So we're not going to do this by hand at all, but you have to know the formulas because, or you should know the formulas, or at least have them written down, because on a test, it might give you R, SX, and SY, and say, hey, what's the slope? And you say, oh, no problem. I'll just multiply this by this and divide by this, and whatever I get, I get. Does that make sense? It's just, I'm not deriving these. The derivations of these do require multivariable calculus. We don't have that here. I'm not deriving them. I am just providing them for you. This is the formula for slope. This is the formula for the Y value of the Y-intercept. I checked 3 times. It is correct. So let's do an example. Did everyone bring their TI-84 calculator? You need one. You need one. Because so much of what we're going to do, not just today, but the entire semester, is going to be calculator work. Things that we do not want to do by hand. So please bring your calculator. If you don't have one, can we at least, is there at least one in every little area of the room so that people can share the one that they do have? Is that a possibility? Okay, so we are going to do an example. And we'll walk through the entire example. And I will show you step by step how to use the calculator for this. So the question is, do heavier people burn more energy? Do heavier people burn more energy? A question near and dear to my heart. Do heavier people burn more energy? So we have data on the lean body mass and resting metabolic rates for 12 women who are subjects in a study of dieting. So we have lean body mass given in kilograms. And then we have resting metabolic rates given in whatever units that's given in. Calories burned for 24 hours. calories per 24 hours. Any people who are like kinesiology majors and whatnot, is that the way that metabolic rate is usually measured? Calories per 24 hours burned? I don't know, okay, anyways. So here's our data. Mass 36.1, 995, 54.6, 1425, 48.5, 1396, 42.0, 1418, 50.6, 1502, 40, another 42.0, 1256. That's 6 of them so far, 6 more to go. I'm going to do all the weights now, just it'll be a little faster. 40.3, 33.1, 42.4, 34.5, 51.1, and 41.2. With 1189, 913, 1124, 1052, 1347, and 1204. So that's my data. And we want to analyze, we're statisticians, we want to analyze this data. First thing I recognize is that I'm trying to see if there's a connection between them, if people burn more depending on weighing more. So I might want to check if there is a strong correlation between them. So the first thing I'm going to do is I'm going to check in my calculator, I'm going to make a scatter plot. So how do I make a scatter plot of the data? What's the first thing I should do? Sorry?
The stat edit.
Yeah, stat and edit answer. Or stat and edit. The first thing I need to do is I need to put the data into my calculator. So again, if you don't have one here, look around. Are there calculators in every little area? If you have one and people around you might not, please volunteer to share. Don't wait for them to ask. People can be very shy, so please volunteer to share. Okay, it's very important that you get this down. Very important. I'll try to share up here. You can see this. So first step. Stats. Hit the stat button. Edit. And then enter. Wow. It's not really a button. But stats and edit, enter. So the first thing you do is you go to stat. Up will pop a page that has, among other things, edit highlighted, and just hit enter. It'll take you to a list screen. You should have a list screen. Put the data in. List 1, 36.1, 54.6, 48.5, 42.0, 50.6, 42.0, 40.3, 33.1, 42.4, 34.5, 51.1, 41.2. So your X, this is step 1. Step 2. X goes into, put X values in list 1, and then put Y values in list 2. So list 2, 995, 1425, 1396, 1418, 1502, 1256, 1189, 913, 1124, 1052, 1347, and 1204. So I'm gonna have this on, I'm gonna show this on the screen if you want to watch the YouTube video later. So here we have all my list 1, list 2, all my data is there. Okay, so are you all with me so far? Next, you gotta make sure that your calculator is ready to do a stat plot. So step 3, hit second, the second button, which takes you to blue mode, and then hit the Y equals button. If you're in blue mode, you'll see that above the Y equals button on your calculator, it says stat plot. We want to do a stat plot. So second Y equals. The very first one, did it say plots off or plot on? Okay, most of them should say off. You got to turn that on. So enter, highlight on. So then enter and on. So you hit enter, you hit on, and what you should see is the highlighted off should now say on instead of off. Are we all with me? Next, hit zoom. Hit zoom. And choose zoom stat.
Do we have to hit second again?
Huh? No, you don't have to hit second again. You can go directly to zoom. Hit-
Can you take this on our test?
Yeah, of course.
Figure out your written.
Sure. So hit zoom and hit stat plot. You should see a scatter plot.
Will that be number
9,
nine?
yeah. You should see a scatter plot. If you do not see a scatter plot, it could be that your calculator just needs a little fine tuning. Some buttons have to be changed in some places. Sorry, geez, okay. Yes,
What if it says DIN mismatch?
okay, then you made a mistake. So let's troubleshoot the mistake. The first thing we're gonna do is we're gonna go to your list and make sure that you have this one. So that, I go down. Okay, so, oh, you're list 3. So you want to do 2 on this first, not just 1 list. So, I don't know if there's a way to have each 2 yeah, you might have to. I think your calculator only goes this one. Yes. Yes. You with the hand up. Yes, you. No one said walking with cars.
Oh, I got here.
If you don't have a calculator, make sure you're close enough to someone to see. You should see a scatter plot. If you do not see a scatter plot, then fix your partner. So plot on. Zoom. 9. Okay, that was yeah. So insert. All right. At this point, you should, yes,
I was gonna ask you. keep it looking.
sure. It's really this important to get this down.
I'm actually using it now. Scatter plot, X is about 1.
Oh my God. Look at that. That's pretty sweet. If I would only would have known that, would have saved me a lot of time. All right. And Philip, you had a question? Yes. This is just to make a scatter plot. I'm going to tell you how to find the best fit line and everything. But this so far is just to do the scatter plot, because before you do anything, you have to ask yourself, do I think the data is linear? When I look at my data plot, my scatter plot, do I get the overall impression, whether it's strong moderates, not weak, but strong or moderates, do I think that this is a linear relationship?
Yeah.
Once you think so, then we can go ahead and say, fine, find me the best fit line. So here's how we do it. Step 5. Now that I have the scatter plot, I want to make my best fit line. So hit stat again. This time, go to the right to calc. You're not doing the edit. You're moving the right to calc. And then you're going to go down to 4, which is lin reg ax plus b. And you're going to hit enter. And when you get there, what do you think you're going to have for X list? What are you going to have for Y list? How about frequency list? Blank. Make sure it's blank. I had an L2 in there from some thing that I did previously. Make sure it's blank. You should have X list. Should be just leave it blank. You don't need it for now. X list L1, Y list L2, frequency list, leave it blank. And the next one, I don't even know what it's for. Store reg EQ. I don't even know what that is. So next one, store reg EQ, leave it blank. And then calculates. So go down to calculates and hit enter. And use this one here. Calculate, hit enter. Okay, we'll get there in a second. On my calculator, I'm going to delete the data. We don't need the data anymore. So I'm taking the data off. If you need to know something, you can ask. It's in the book. This is what my calculator gives me. First, it tells me that I have y equals ax plus b. What's my a? 24.026066662. I like to write them all because I want maximum precision in the next step. What do I have for B? Now, you might not have this. If you don't, we got to fix it. But I have an R squared and an R. Does anyone have an R squared and R with theirs? You do. Does anyone not? Okay, so we're gonna fix your calculator to do it, but for now, I'm just gonna put these in here since we're here anyways. Okay, so this is a one-time fix. What I do now, you only need to do one time. Once you have it done, you don't got to worry about it again. Hit second catalog, the very bottom of the thing on 0, hit second catalog. And scroll down to diagnostic on.
Wait, where's that catalog?
Bottom, second on top, catalogs on bottom. Go down all the way to diagnostic on, enter, enter. It's got to say done. So this is a one-time fix, Second, catalog, diagnostic on, make sure it's on. And then redo this step here.
Do we click enter?
Yeah, make sure it says done. Stat, calc, lin reg. Go down, it should now say all of this, yes.
So after we click calculate,
Sorry, I can't hear you.
after we click calculate, it says the argument
Guys, sorry,
So after we press calculate, it shows the R squared and the R will be after that.
stop, pause. Let's wait for everyone to catch up, make sure we're all on the same page.
What do we do after second calculus?
Second what?
The second catalog.
Diagnostic on. Go down to diagnostic on and make sure it is on. Once it's on, you should get the R and the R squared value automatically. Yeah.
That's pretty similar. Second catalog, one of these. Did any of these?
It's not hyperbolic. So wait, so do it again. Go back a second. Seconds. Catalog. This is hyperbolic. I don't want hyperbolic.
So what I decided, because I think there was a setting at the beginning that changed.
I don't know why you know this like that. I don't know why yours. Catalog. Is there a way to scroll left and right? This is what I found. No, it's nothing like that. It's internal working with the calculator. It's not a math thing. It's a diagnostic. It's gonna make sure, maybe format? Format maybe? No, not format. Those. Programming maybe? No, I don't know.
What would we call
Well, on this is called diagnostic on,
it? Okay.
but I don't
It's
know.
giving you the R squared.
Well, it'll give you R squared and R.
What is that? What's the name for that?
R is correlation.
Correlation.
Yeah, huh? Shh, guys. Yes,
So I did that and it said done, and then I clicked clear and I tried it again and it didn't work.
I'm gonna check
It
it
didn't give me R squared.
What are you talking about?
Hey, hello.
Oh, wow, okay. that
We're
works.
changing. All right. So. All right, guys, we're not done. Got more to do. What do we have with R? What is this called? The correlation, strong or moderate?
Strong.
Well, what do we say? About 0.9 or higher is strong, right? So it's strong to moderate. Strong to moderate. What's the slope of my best fit line?
24.
Slope is the number in front of the x. Slope is 24 point whatever. What's the y-intercept, or at least the y-value of the y-intercept? 201. So now do the following.
Professor,
Yeah,
what does R squared mean?
we'll get to that. For now, R squared is just R squared. Take the correlation and square it. That's R squared.
Why?
You'll see. R squared is a more important quantity than R. We'll get to that. For now, hit the y equals. Hit the y equals button. And on the first line, put in our equation, 24.026066662x plus 201.1615996. The y equals, and then enter best fit equation.
When you
Enter
said
best-
on Y2, we put in the B.
No, y1. Y1, very first one.
For some reason, it's automatically cubing my A.
What?
So 24.026066662x plus 201.1615996. Yes,
Up again.
I just want to know what the X is.
the x.
Yeah.
Right up top, says x, right in the
Oh,
middle.
the waiver?
It says x d theta n, right, yeah, the link button. Give it x.
Uh,
And then hit graph.
It says cosine and then an open parentheses.
Huh? Cosine.
he just. Yeah. Oh, correct.
So at this point, you should have a scatter plot, and you should have a line, the best fit line that goes directly through the data. Yes. It says XT theta M. See the word link? 201.
Yeah, just
Oh, yeah. Go on. Go on. When you say hello, Mr. User, can you find me how to use a TI before best fit line? It'll walk the whole thing. Yeah, huh? You guys, I can't hear. Huh?
I did, but it don't show the line.
All right, so what more? Yes, what do you have to?
I think we just have to like,
Hit the word graph, top right button.
yeah, bottom.
Hold on. What's wrong?
So I'm writing it down.
What the hell? All right. So if you don't have it, you can watch this YouTube video later, of course. You can go on YouTube itself and just do a Google search for how do I find the best fit line on a TI-84? And somebody will walk you through it. They'll have like the calculator display up on the screen. It'll be a lot easier to follow than this. I don't care where you get it from, just make sure you get it. You have to be able to do that. So question A was make a scatter plot. It says there's a quite strong linear relationship with correlation R equals 0.876. So we actually calculated our R 0.876 and it's moderate to strong. B, find the least squares regression line, add it to your scatter plot. We did that. C, explain in words what the slope of this line tells us. The slope of the line is 24 approximately. The slope is 24. 24 what? No. No. No, these are good guesses. No.
Average increase?
Yes, average increase of what? Be more specific. No. No, it is an average increase of calories burned, but you have to be more specific than that.
Per
day.
Per,
24 hours.
no, the data is for 24 hours. Per, what's the unit for my x-axis? Kilogram. Per kilogram. So 24 means for every additional kilogram, your metabolic rate is predicted to be 24 point whatever higher. Okay, think about the scatter plot itself. What was the unit for the x-axis? Kilograms. What was the unit for the y-axis? Calories burned per 24 hours. Let's say calories burned. So when I have my slope is the rise over the run. Delta y over delta x. This has units and this has units. Your slope has units because y and x have units. What are the units of y? Calories burned. What are the units of x? Kilograms. So the units of slope being 20, the numerical value for slope is 24. The units are 24 calories burned per kilogram. So every additional kilogram, my data predicts that I will burn 24 calories more for every 24 hours. Our slopes have physical significance. What is the y-intercept telling me? This one's a little trickier. Be more specific, because even something like starting point, even if that's correct, you're not giving me anything in the context of the problem. I want something in the context of the problem. Yes.
Would that be like the average calories?
No. Yes. Yes. Well, since you're on the y-axis, what is the x value for this point? What's the x value? 0. It's claiming that my metabolic rate will be about 201 calories burned per 24 hours if my mass is 0 kilograms. Does that seem like it's a realistic value for a person of 0 kilogram mass? Have you ever seen a person of 0 kilogram mass? Will you ever see a person of 0 kilogram mass? Maybe? I think we have to understand what a kilogram is, right? You have a hair, one hair, and you're already more than 0 kilograms. It's impossible to be that low. So why do we have this result? This is a nonsensical result. Our data is predicting that if you have 0 kilograms, you will have a metabolic rate of 201. That's nonsensical. How can we trust any of our data with a result like that? No, there's an answer. Nike's wrong. You don't just do it, you explain why. Go back to your data for a second. What's the lowest value of kilograms anywhere in our data?
Wasn't like a zoo, 32.
32 sub-point something. So how are you taking your data, which was only found from 32 to whatever, and trying to apply your data way outside of the location of your data? What do we call that? I gave you the term last time.
Outlier.
No, outlier is a data point that doesn't belong. This is when you try to take your data and infer something way outside where the data is located. Extrapolation. You can't extrapolate. Our data only holds from here to here. I have no data less than that or above this. I don't know what's going to change. Can you imagine? I think I gave you this example last time, but imagine you're graphing babies' heights versus their age. When they get to a certain age, it kind of tapers off, correct? We don't keep growing. What if I stopped my data here and said, use it to predict what's going to happen when someone's 80 years old? What will my prediction be? Like 9,000 feet. You can't take the data that applies for this area and apply it somewhere else. So I have no idea if my trend would continue the way it has been between 32 and whatever. So while the y-intercept is 201, it's nonsensical data, it's nonsensical results if I try to use it, but within my data is perfectly fine. I'm not using that in my data, it's just the y-intercept. Yes.
So the calculator is just extrapolating the data.
Well, the calculator is computing the best fit line. It does not know whether or not your trend continues indefinitely. So it's giving you the line, but you have to use common sense and say, can I use my line over here? Can I use my line over here? Or do things change eventually? And my data doesn't tell me what happens then. In this case, it's giving me a nonsensical result because it's trying to apply the data where it's not allowed to. The calculator doesn't know what to do. You have to know what to do. Yes.
So like the sample area, is that like the range or what do we call it?
We don't really call it anything, but if you want to call it the range of applicability, that sounds like a great thing to me.
Okay.
Okay, I've never really heard a term for it. It's just, you can use it here and you can't use it there. So range of applicability sounds really nice. How about domain of applicability? That's an extra syllable, so you know it's nicer. I like that. Domain of applicability. So today, mostly so far, there's been very few actual concepts, but a lot of get to know how to use this other calculator. You have to be able to make a scatter plot, to graph a best fit line, and I mean, you don't really need to know how to graph a best fit line because I don't really imagine many problems will ask you to do that, but you should understand how to graph a best fit line and certainly know how to come up with the correlation. It's a one-time fix. If your calculator does not do it automatically, do the diagnostic on thing, you'll be able to do it one time and don't reset your calculator ever again. And if you ever reset your calculator, just remember how to go back to diagnostic on and put it in there. My high school kids, when they take math tests, they have to reset their calculator. Some of them come to me during a test and say, I don't know how to do the R value, it's not there anymore. I say, tough shit. I told you, you're gonna need to reset this during a test and you're gonna need to know how to do it. And if you don't, it's on you. Well, it's on them. Yes,
Why is your high school class harder than this one?
it's not harder, they learn different things.
Oh,
They learn different things. But the internet, listen, without pulling punches at all, the math level in America is not considered to be the greatest in the world. This is a fact, statistical fact. And what they're doing in my high school, which is an international system, uses a program from Europe, which is more sophisticated.
so what math are they in right now?
My students are doing statistics, they're doing probability, they're doing combinatorics, they're doing graph theory, they're doing calculus, they're doing, it's like all over the place. Matrices, linear algebra, seniors high school. But they're not learning like they have 2 chapters of calculus. They do a little of this, a little of this, a little of this. I can take an entire year and not finish calculus. They're doing 2 chapters. So they're covering a little bit of a lot of things, but they don't really cover anything in major depth. I'm not a fan of the system, to be honest, but it is what they're doing. Okay, now question for you. I'm about what? 75 kilograms? What are you laughing for? Who just laughed? Who just laughed?
Yeah, what does that mean?
110.
Someone who laughed knows what it means. So, okay, more realistic. I'm about 100. I'm about 100. I'm a lot, okay? I'm like, let's say 130 kilograms. Is that in the data, by the way? I'm actually more than that, but let's not go into that. Is 130 kilograms in the data set? I don't remember. What's the largest value?
It was like 50 something.
Oh, because it was fine, 50 something. Okay, so let's say somebody comes along and says, hey, I'm 50 kilograms. What's my metabolic rate? I go, I can't tell you for sure, but I can give you a pretty good prediction. What would my prediction be if somebody came along and said, I have a mass of 50 kilograms? How would I predict their metabolic rate for my data? Yes.
White was 8 times 120 mass and plus 21 B.
So one more time, I'm sorry.
Y equals 8 times U mass was B.
Yeah. This best fit line is my predictive line. Any data point that applies, this is women, I believe it was women. 12 women are the results of this study. So I won't want to use this data for myself, not only because I'm outside the range of data, but just because I can't really know for certain whether the same data would apply for men as for women when it comes to metabolic rate. So, but if a woman came along and said, hey, I'm 50 kilograms, I would say, wonderful. I have my data, which gives me my best fit line. So I'm going to plug in 50 here, and whatever number pops out, that's going to be my best guess for what your metabolic rate is based upon my data. Okay, the best fit line is a predictive line. It takes the data points and says, we believe this is the best line. So anyone who comes along in the future and says, what is my Y value, as long as they fall in my domain of applicability and are appropriate for whatever scenario is going on here, I just plug them in and see what I calculate. In this case, did anyone actually do it just now, or no one did it? So actually, here's a cool way of doing it on your calculator. Watch this. Go back to your graph. Watch this. Go to your graph. Hit second calculate, or second calc in the very top line, second calc. And you should see a list of 7 commands. Second calc. The top line says calc. Second calc. You all see it?
Yes.
Go to value. Hit the very first one. Enter value. And just put in a value of 50. What Y value pops out? 1402. So I don't even have to do the math. The calculator told me that if X is 50, my Y value is 1402. So I would predict a metabolic rate of 1402 for that woman who came along and said, I have a max of 50 kilograms. Calculator does so much of our work for us. Now, someone asked earlier, someone said, what's R squared? Been on the board the whole time. One person said, hey, what's R squared? I said, oh, it's easy. R squared is R squared. And the question is, great, why do we care? And the answer is that R squared has a much greater physical significance than R does. This is what R squared tells us. Let's look back at this problem. We believe, based upon our scatter plot, that different kilograms are going to produce different metabolic rates, correct? That seems to be what the trend is, right? As the kilograms go up, the metabolic rate goes up. We have a nice, relatively strong linear relationship. Does it seem that the amount of kilograms is the only determining factor in what the metabolic rate should be? Would every 2 people on the planet with the same kilogram have the same metabolic rate? So while our model is telling us that kilograms is a big factor in metabolic rates, it's not the only factor. What are some other factors that might play a role besides kilograms in calculating someone's metabolic rate? Muscle mass, percentage.
Yes.
Okay.
But
Genetics. How tall the person is, what they eat, how old they are. There's lots of things besides kilograms that should have a factor in metabolic rate. We're only considering one. We're considering one thing. We're saying kilograms to metabolic rate. But there's so many other things that we're not considering. So obviously the Y values are not all the same. They're going up. They're all, look at their scatter plot. They're all over the place, right? There's 2 reasons why the Y values are not the same. One reason is because the kilograms are not the same. The second reason is everything else that we're not considering. So if you had to divide how much of the variety in Y comes from the kilograms versus how much of the variety in Y comes from everything else, how much would you say came from the kilograms? Give me an actual number. What percent of the total variation in Y can be explained by kilograms as opposed to all the other things that we're not considering,
77%.
77%.
But how
So-
does it assume that? How does it find?
This is math beyond the level of this course. As so much of what we're gonna do is, as so much of what, this is one of the reasons that statistics is very hard to teach. Because I can give you so much information, but not all the reason why that information is valid. So much of what I can do, I'm limited by just, you're not ready for the math. In this case, not your fault, it's very few people are. 76.8% of the variety in Y can be explained by the variety in X. The other 23.2%, everything else. All the other things that we're not considering here, these all play a factor. That's 23.2% of the reason the Y values change. That's why a big R squared value or a big R value lends me to believe that I've hit upon the main reason. If I have an R squared like 99%, 0.99, that leaves little room for things that I'm not considering. Pretty much all of the reason the Y values change is because of X. Yes,
Is there a certain threshold, like if it's less than 50 or 60%, like it says something else?
well, this is where the strong moderate weak comes in. Because an R value of 0.9 corresponds to an R squared value of 0.81. 90.9 squared is 0.81. That's why with a threshold of 0.9 for strong, the corresponding threshold for strong for R squared is 0.81. If this drops to 80%, this becomes 64%, 70%, 49%, which means if I have an R of 0.7, that means less than half of the reason of the Y values changing is because of the X. 0.7 seems high from 0 to 1, but R squared is less than 0.5. At that point, we're already pretty weak. Does that make sense? Questions? Yes.
The R squared would be the Y percent change to the X.
R squared is the percent. How do let me try to say it a different way. The R squared value gives what percent of the variation in Y that is explained by the variation in X. So if I get 77% like I do here, my claim is that 77% of the reason why the Y values are changing is because the X values are changing. The other 23%, all the things that I'm not considering in this study. This is why when I actually do a study, what do I try to, if I'm actually coming up with some medicine or something, and I go to the FDA and say, hey, I believe I have this wonderful medicine, it's gonna cure cancer or whatever, and we do a study. What do we try to do in that study? In general, we try to limit any other factor that might play a role in the results, right? Oh, men and women? Well, let's separate them. Make sure that there's no variety that comes from that. So we can focus on the men and women separately. Oh, age group, let's separate that. Oh, smokers, non-smokers, let's separate that. Because we don't want to skew the results with the other variety of variability in there that's different than what we're trying to focus on.
R squared equals 1.
I got R squared of 1, and we're saying the entire reason why the Y values change can be explained solely because of the X, and that's why they all fall on a line.
That's the strongest.
You can't get better than that.
Strongest correlation.
The strongest correlation, the strongest R squared. Does that make sense? A little bit? People believe, they have this erroneous belief that you go to a college class or high school class or any class, and you're lucky enough to have a professor that's really great, or maybe you're unlucky enough to have one that really sucks. But let's assume it's the first scenario. Wow, what a great professor. I understand everything this professor says. I understand. I get 100% on every test because they're so clear. I don't got to do any work on my own. I got it. I got it. I'm done. That will never happen, ever, in your entire career as a student. As an example, Anyone here ever heard of Richard Feynman? Richard Feynman was a Nobel Prize winning physicist who was renowned for being one of the greatest physics teachers of all time. And I had a teacher here when I was a student. This is going back 15 years. His name was Paul Lee, since retired. He was a student of Richard Feynman's at Caltech. You guys heard of Caltech? Considered one of the greatest universities for science and mathematics in the world. So we're talking about an amazing lecturer and probably arguably one of the most brilliant men I've ever had the pleasure of knowing. My instructor, Paul Lee, was just out of this world brilliant in a subject they both found fascinating, that they were both interested in. And he said he'd come out of every class thinking that he had a complete understanding of the material, sit down to do the homework, and have no idea where to begin. So we're talking, this is not me, above average teacher, I like to think. You guys, above average students, you like to think. What chance do you have to come out of a class and just get it if some of the greatest minds can't do that? It's nonsense to believe that you can do that or that you should do that. You have to come out of a class saying, I got a lot of what he said, but it's kind of a jumble. So let me go over it and solidify it later. So if you leave here saying, I have no idea what this guy's talking about, that's normal. It doesn't mean it's a bad teacher or that you're a bad student or it's a hard subject or an easy subject. It's normal. But I see on your faces, or at least the top half of your faces, like some of you, I can just tell, you're like, what language is he talking? You have to go over this stuff on your own later. You have to. You will not get it on a one pass. So don't expect that. Okay? You have the YouTube videos. I put them up every day when we're done. You should be reading the book or at least skimming the book. I think someone mentioned last time or a couple times ago, the book is very verbose, very long, but you should be going over the stuff. So if you're not getting it, it's okay, I promise. You have to work at it. The general rule of thumb is in college, every hour in class, an average student should spend 2 hours on their own time. So we meet for 100 minutes twice a week, right? 200 minutes a week. So that means every week you should be putting in 400 minutes. That's 6 hours, 40 minutes. So we're 2 weeks in. Did anyone here, honestly, tell me that you're putting in roughly 6.5 hours a week so far in this course on your own time out of class? Statistics, it's not easy. The concepts are foreign. It's not just basic algebra. Oh, I'll just subtract 3 from both sides and solve for y. Oh, okay, I got that. The ideas are complicated. They're different. The logical chain, well, I know this, therefore I know this, therefore I know this, therefore I know this. These are not intuitive at all. You have to work at them. So please do so. Put in the time. If you do that, you'll see it actually gets easier as it goes along. If you don't do that, then in a couple of weeks, you're going to stop coming to class. Why? Well, I don't get anything he says anyway, so what's the point? I hear that all the time. Not my students, of course, but other students. Oh, I stopped going to that person's class. I didn't get anything the person was saying. Well, maybe they are bad teachers, certainly possible. Or maybe you fell behind to the point that you just weren't ready for every lecture. That's probably a more likely scenario without knowing the specifics of the situation. So be ready for the lecture. Bring your calculator next time. Make sure you know how to use your calculator next time. We didn't finish the chapter today. I really took my time on this and went around the room a lot to make sure that whoever was working on their calculator had it. We will finish the chapter next time. The exam is still scheduled for the following Tuesday, 2 weeks from today. And don't forget, we will have a quiz on chapter 3 on Thursday as well. Thursday, yeah, the homework's due on Thursday, huh? Um,